something extraordinary is passing through our solar system. It's called 3i Atlas. And it's not just any comet, it's an interstellar visitor, exhibiting behaviors that have left astronomers baffled. In this video, we'll explore what scientists have discovered so far, what remains a mystery, and why this object could hold important clues about the origins of water, organic compounds, and even life itself. Welcome to a journey across the stars. 3i Atlas was discovered on July 1, 2025, by the Atlas Survey telescope in Chile. Almost immediately, astronomers noticed something unusual about its orbit. Its trajectory is hyperbolic, meaning it isn't bound to the Sun by gravity. Instead, it's traveling from interstellar space, making a single pass through our solar system before continuing on its journey. This places 3i Atlas in an exclusive club. Only 2 other interstellar objects have ever been confirmed. Oumuamua in 2017, and 2i Borisov in 2019. 3i Atlas is faint, much too faint to be seen with the naked eye. Its brightness is expected to remain below magnitude 11.5. Estimates also suggest that this object is incredibly ancient, perhaps between 7 and 14 billion years old, which is older than our solar system itself. A faint, ancient traveler from another star system. But what makes it truly remarkable is what it's doing, even at great distances from the Sun. One of the most astonishing discoveries is that 3i Atlas is releasing water vapor, even though it's far beyond the distance where comets normally heat up and sublimate. NASA's Swift Observatory detected ultraviolet signatures of hydroxyl molecules, a telltale sign that sunlight is breaking apart water molecules in the comet's coma. At the time of the observation, 3i Atlas was nearly 3 times farther from the Sun than Earth, a region far too cold for ice to sublimate in the usual way. Researchers estimate the comet is losing water at an astonishing 40 kilograms per second, equivalent to a fire hose blasting at full power. Even more surprising, roughly 8% of its surface appears to be active. That's much higher than typical solar system comets, which usually have only a few % of their surface producing outgassing. How is this happening? One hypothesis is that microscopic icy grains are being released from the comet's surface. As sunlight warms these grains, they sublimate while floating in space, creating a sort of extended atmosphere around the comet that produces water vapor, even though the nucleus itself remains cold. This phenomenon challenges traditional comet models, suggesting that interstellar objects may behave in ways we haven't seen before. What do we know about the physical characteristics and path of this object? Early observations hint that 3i Atlas may be larger and more massive than initially thought. Some estimates put its mass at over 33 billion tons. The nucleus size remains uncertain, but early measurements suggested it could be up to 20 kilometers wide, roughly the size of a small city. The comet's closest approach to Earth is projected for December 2025, at a distance of about 1.8 astronomical units, or 170 million miles. It won't pose any threat, but this will be a prime opportunity for telescopes to study it in detail. Earlier, on October 3, 2025, it passed near Mars, coming within about 30 million kilometers. Instruments on Mars orbiters and possibly even surface rovers may have captured data during this flyby. After its passage through the inner solar system, 3i Atlas will swing back out past Jupiter and eventually return to the depths of interstellar space. Understanding the composition of 3i Atlas can tell us where it formed, and what kind of environment it came from. Spectroscopic studies by observatories including the James Webb Space Telescope have revealed that its coma contains water vapor, carbon dioxide, carbon monoxide, and trace molecules such as carbonyl sulfide. The ratio of carbon dioxide to water is unusually high compared to comets in our solar system. This suggests 3i Atlas may have formed in an extremely cold, distant region of its home star system, perhaps far beyond what we call the frost line. Preliminary isotope measurements even hint at differences in carbon isotopes compared to solar system material, although more data is needed to confirm this. In short, its chemical fingerprint is unlike anything we've seen from local comets. With all this unusual behavior, it's no surprise that speculation has begun to swirl. Harvard astrophysicist Avi Loeb, known for his controversial views on Oumuamua, has suggested that 3i Atlas's trajectory through the solar system, passing near multiple planets, could, in theory, resemble a planned reconnaissance path. He's also noted unusual light patterns, such as a glow that seems to precede the object, rather than trail behind it like a normal comet tail. Could 3I Atlas be more than just a comet? Could it be an alien probe? At present, there's no hard evidence to support that idea. No radio transmissions. No signs of propulsion. No engineered structures. The unusual behavior can also be explained by complex natural processes, dust jets, asymmetric heating, or fragmentation. While the alien probe hypothesis is intriguing, most scientists caution against drawing conclusions without extraordinary evidence. Over the coming months, astronomers will be closely monitoring 3I Atlas for more spectral data to refine our understanding of its composition, changes in its coma and tail to study how activity evolves as it moves closer to the Sun, trajectory deviations, which might indicate non-gravitational forces at work, observations from multiple vantage points, Earth, Mars, and space telescopes, potential polarimetric studies, which analyze how light scatters off dust to reveal grain properties. These observations will help settle many of the current puzzles and give us a clearer picture of this extraordinary visitor. The implications of studying 3I Atlas are profound. It provides a unique glimpse into another star system, carried here by natural forces over unimaginable distances and time. It could reveal new insights into cosmic chemistry, the distribution of water and organics, and the diversity of planetary systems. If objects like this are common, they might have played a role in delivering the ingredients of life to young planets across the galaxy, including Earth. Even if it turns out to be nothing more than an unusual comet, 3I Atlas is already expanding our understanding of how the universe works. In summary, 3I Atlas is an ancient traveler from another star system. It's leaking water in a way we've never seen before. It's chemically unique. And it's giving scientists a rare opportunity to study interstellar material up close. Whether it's a natural wonder or something even more mysterious, 3I Atlas is a reminder that the cosmos is still full of surprises. Thank you for watching.